All right, so in the notes for 13.4a, we were also solving absolute value inequalities. This is just the second day of that. Notice how the essential question says, how do I solve absolute value inequalities when the absolute value bars are not already isolated? And you'll remember from 2 lessons ago that isolated means that they're by themselves. So the notes today actually only have 2 examples in them. We're just going to be writing on the front side of the paper. But it's just a reminder to you that sometimes there's going to be examples of inequalities where absolute value inequalities where you need to do something first. And so just like we did in 13.3b when we practiced doing more than one thing at a time, I'll use a red pen today to show you the additional step that you have on each one of these problems. So in the space for the notes for today, you're just going to break it up into 2 pieces. Here's your example number 1. And the directions for this one say to solve and graph. So we'll go through the steps that we need to go through to get the solution to this question, and then we'll also go ahead and we'll graph it too. So here's my inequality. It says the absolute value of 2x plus 1, and that's inside the bars, minus 4 is less than 5. And so that's the absolute value inequality that I'm going to solve. So this says that the absolute value of something is going to be within a certain amount of a distance from 0. And so since it's within a certain amount, that means that it's going to be an inside absolute value, not an outside absolute value. And so over here off to the side, in a second, we're going to write down which kind of absolute value it is. But if you compare this to yesterday's notes, or the notes from the previous day from 13.4a, the only thing that's different about this compared to yesterday is that I have to start by adding the 4 to both sides to get the part that's inside the bars by itself. So 2x plus 1 is less than 9. Once I have the part that's inside the bars all by itself, my job is to figure out which kind of inequality it is. So just like I talked about previously, it has to be 2x plus 1 has to be within 9 of 0. Within 9 means that it needs to be inside of 9. And so if you think about the pictures for the 2 different kinds of graphs for compound inequalities, being within something means that this is going to be an AND graph because it's going to be shaded in the middle when we think about where our answers are. The trick for this that you practiced yesterday is that if it's a less than symbol, the joke is that it's less than, and so that gives you the clue that it's going to be an and symbol. Anytime you see a less than sign, it means it needs to be within a certain amount, and so that's where the and comes from. So when it comes to solving this, when I set up my next thing, it's not an or, it's not an outside problem, it's an and inside problem. And so I'm going to solve this knowing how the answer is going to look. So because this is a less than symbol, I'm going to write the 2x plus 1 down in the middle. I'm going to keep this less than 9. And then I'm going to come over here to the other side of the 2x plus 1. I'm going to put my negative 9 over there, and I'm going to put my second inequality symbol. So this 9, again, just like we practiced in the notes from the previous lesson, this 9 comes over here, and it comes over here as a negative 9. You have to remember that. So you're looking at the direction of the inequality symbol, and that's helping you decide how to set this up. If this symbol was facing the other way, then I would set this up and I would solve it as an or problem because it would mean that it needed to be outside of a certain distance from 0. So you really have to make sure that your brain stays engaged when you're practicing these notes and doing questions like this. Let's see. So to solve this, I'll minus the 1. That'll give me negative 10 is less than 2x is less than 8. And then I'll divide all 3 pieces by 2 to get my answer to the question. So when I divide all 3 pieces by 2, I get that my answer to this question is negative 5 is less than x is less than 4. So that's the answer. Notice that it looks like an and inequality should look, and that's good because it's supposed to. And then if I were to graph this inequality on a number line, I would have an open circle at negative 5. I would have an open circle at 4, and my answers to this inequality would be the numbers that were in between these two, because these are a certain distance away from 0 based on the values in the inequality that I solved before. So all of the solutions to this inequality would be the numbers in here. Again, one more time before we do the second and last question, is that you have to be able to look at it, and you have to be able to decide based on the direction of the symbol, what does it mean? and then based on the direction of the symbol and what it means, how do I set up solving my answer? So you picked to solve it this way because this was a less than symbol. In example number 2, and this is the last one we're going to do in the notes for today, this is an example of the other kind of inequality. So the directions still say solve and graph. And when you look at the way that the inequality is written in this one, it looks almost exactly the same at the start. This one, the absolute value of x minus 6 is greater than or equal to 8. So when you look at this question right away, it looks just like the thing that we did up above. It's almost like you wouldn't even be able to know that it was different unless you noticed the direction of the inequality symbol. But before I make any decisions about that, notice that the absolute value of x isn't all by itself. So I'm going to plus the 6 to both sides here and here to get the absolute value of x part all by itself. So the absolute value of x is greater than or equal to 14. So this is where I have to stop and recognize that this question is different than when I solved this when it had an equal sign, because this says that the distance the number is away from 0, that's what absolute value means, the distance it is away from 0, has to be bigger than or equal to 14. So this question has to be at least 14 away from 0. That can happen both in the positive direction and it can happen in the negative direction. Whenever you see a greater than symbol, that's your outside absolute value or your outside inequality. It has to be at least a certain distance away from 0. So because of that, I'm going to set up and solve this one like I would solve an OR inequality. Remember, the trick from the notes from 13.4a was if it's greater than, great or than, and so that's kind of the way that you can remind yourself that this is going to be an OR problem. So it is true, and you might want to write this down, that all less than or equal to problems will be and then all greater than or equal to problems will be or. And so that's something that works all the time. Let's come back here to where it said and write down less than. Again, a play on words, but it's to help us remember that it's an and question for that one. And then down here for or, we'll come over here to the side and we'll write great or than. And so it's just supposed to be a little way to help you remember it. It's not really mathematical, but it gets the job done. So if the absolute value of x has to be greater than or equal to 14, that means two things. I'm going to take whatever's inside this one and come over here, and I'm going to say x has to be greater than or equal to 14. That's my one. Or, and then I'll come over here and do the other one. X has to be, and then this is important to remember from yesterday. You're going to flip the direction of the inequality symbol, and then you're also going to change the 14 to be negative 14. So two things change. The direction of the inequality symbol changes, and then this number is positive, and then this one over here is negative. Notice that I write the word or in the middle because I know that that's the way my answer is going to be. Normally, there's going to be some other numbers in here with the x, and you're going to have to go through and solve them. So for example, if there had been a 2 here on the inside next to the x, then these would both have 2's as well, and I would be dividing by 2 to solve it. But in this example, I don't have to do that. I'm just looking at this one example right here. So I'm finished because there's nothing to solve here and there's nothing to solve here. So my answer to this question is x is either greater than or equal to 14 or x is less than or equal to negative 14. And so these two sets of numbers would produce a solution that was at least the certain distance away from 0 that it was supposed to be. When I graph this, I'm going to picture negative 14